Ever pondered the intricate dance between data processing and data storage in the world of big data? It's a fascinating topic that brings to light the interplay between two critical components of the information age. Data processing and data storage might seem like two sides of the same coin, but they are as different as night and day, each with their unique roles and responsibilities. On one hand, data processing is the transformative step. Picture it as the chef in a high-tech kitchen, taking raw ingredients, in this case raw data, and turning them into something useful, palatable, and informative. It's an active, dynamic process that involves cleaning, transforming, and modeling data to extract valuable insights. Data processing can be real-time, where the data is processed immediately as it comes in, or batch processing, where the data is processed in groups or batches. On the other hand, data storage is the silent, steadfast custodian of information. It's the pantry where the chef stores all the ingredients. It's a passive, static process that involves holding on to the data until it's needed for processing. Data storage can be on-premise, where the data is stored on physical servers in your organization. Or it can be cloud-based, where the data is stored on virtual servers provided by a third-party vendor. Now imagine trying to make sense of zettabytes of data without a system to manage it all. Enter Hadoop, an open-source software framework that allows for the distributed processing of large data sets across clusters of computers. It's like the master conductor of an orchestra, ensuring each instrument, each data node, plays its part in harmony. Hadoop uses a storage part known as Hadoop Distributed File System, HDFS. Picture HDFS as a massive virtual filing cabinet spread across many machines, providing high-speed access and fault tolerance to ensure no data is lost. And for the processing part, Hadoop uses a component called MapReduce. Imagine MapReduce as a fleet of diligent librarians, each assigned a section of the library to organize and summarize. To help visualize this, let's consider a practical example. Say a large retail company wants to analyze customer behavior patterns from their numerous store locations. The raw data, including transaction details and customer profiles, is the ingredient stored in the HDFS pantry. The MapReduce librarians then swing into action, processing this data to reveal patterns and trends. The result might be a new marketing strategy tailored to specific customer segments. In summary, data processing and data storage are two vital components in the realm of big data. They are distinct yet interconnected, each playing a crucial role in turning raw data into valuable insights. Hadoop, with its HDFS and MapReduce components, bridges the gap between these two, providing a robust and efficient system for big data analytics. So the next time you marvel at the speed and precision of data-driven insights, remember the intricate ballet of data processing and storage that makes it all possible. It's a dance that's continually evolving, shaped by the ceaseless rhythm of the information age.